Okay, so here, let me open up this. Perfect. I'm just getting Colab open. Just perfect. Okay, yeah, don't need that. Okay. To do a review of what we did last time, because last time we had a lecture was a week ago, right? Because we didn't have one Tuesday, and Wednesday we had the test, right? So it's been a week. So just to review, we were talking about while loops, which is like a condition, but unlike a condition, this keeps repeating until the condition is not true anymore. Okay? If the condition is never true, we skip over it like an if statement. But it continually repeats until the condition is not true. So I'm going to take this, copy it. And by the way, this is like your general structure for a for loop. Okay? You've got some counter. If you want the for loop to repeat some number of times. Some counter, well, the counter is less than the number of times you want to run it. You do something. Here I'm just printing out the counter, but you can do whatever the hell you want here. Increment the counter. That's the general structure. And if this is throwing you off, I hit run. What does the code say? I guarantee you, if you've made it this far, you can look at this code and follow along. There's no steps to skip. Counter is 0. Is 0 less than 10? True. Print out 0, increment counter. Counter is now 1. Is 1 less than 10? True. Print it out, increment it. Is 2 less than 10? And so on. Why did it stop at 9? Well, consider. Okay, 9 less than 10? Yeah, print it out. 10. Is 10 less than 10? False. Right? So that's why it stops. It didn't do it for that time. Okay? So that's the general idea. And then I gave you that little bit of warning, like trace by hand, but as soon as, okay, here we actually have two values that are changing. Okay? We've got result, which is being modified in the loop, and we have n that's being modified in the loop. It's one thing to keep track of one value in your head as you're going. Once you've got more than one, good luck. You're going to want to write down, you're going to need your pencil paper, and you're going to want to write down okay, how are these changing every time to make sense of what's going on. Once you've got anything more than one variable to keep track of, you're not going to keep track of it. So write it down, okay? And then algorithm. All the functions, everything we've seen before has been an algorithm. But an algorithm is just a description of steps like we've talked about, right? Like driving directions, a cookie recipe. So here's an activity. Start from this general idea here. The activity is, and it really is, and you don't have to write it down. You can talk to the person sitting next to you. I don't care. But step 1, I want you to write, what is the algorithm to add up all of the even numbers between 0 and n. I don't care if it's inclusive or not. It doesn't really matter. Just add up all the numbers between 0 and n, okay? All the even numbers between 0 and n. So, before you write any code, though, think, write, talk amongst yourselves, what is the algorithm? Don't think about the code. Think about what are the steps. What are the steps you would do in the most basic things? Okay, I would start at 0. Okay, I would check. Okay, 0. That's what I want you to do. So I'm going to give you a few minutes to do that. Come up with that algorithm. And then after you have it, write the actual function and see if you can get it right. I'm going to give you a few minutes for this one because it's a good one. Okay? You're trying to make it like Java really hard, aren't you? Pardon? Oh, fine. You're making, yeah. What's up?
I was just wondering, when are your office hours?
Read the syllabus, but to answer you, it's 10 to 11 on Tuesdays, Wednesdays, Thursdays, and Fridays.
Oh, okay.
Yeah.
Okay. Thank you.
What's up?
I made something like this and it passed through.
Mm-hmm.
Why isn't it printing?
Because you never called the function.
I never called it.
Yeah,
so,
call the function down here, like unindent. Remember to call like int sum n or something.
So int underscore sum, and then just n.
Yeah. Well, raise your hand if you're done. Okay, cool. Now, I'm gonna work through like one step and then I'll let you go on a little bit longer. Okay, if we need to sum all of the even numbers, what do we have to do? We have to look at each number, right? Okay, but we only really need to look at the even ones. So we have a couple of options on how to do that. But to start simply, let's say, well look, if I need to look at all the numbers between 0 and n, check if they're even, and if they are, add them together. Okay, so let's start by looking at all the numbers between 0 and n. Okay? And then okay, so what did I do? Look, obviously this is not a working solution, but here's what I did. I'm like, okay, well, let's start with the counter 0. Well, counter is less than n, right? Basically, I want the loop to run and have counter go from 0 to n. Here I'm going to do n exclusively, okay? So add up all the numbers up to, but excluding n that are even, I guess. But it doesn't really matter. We could change it by making this an equal sign. It doesn't matter. In here, all I'm doing is printing out counter in n, and then incrementing counter. That's it. That's all this is doing. Now, if you're looking at this and you're like, hey, you put a print inside a function. You told me never to do that. I'm building the function right now. I put it there just to see how it's going to react. I'll get rid of it later. It's called, like, throw prints in there wherever you want to keep track of values. I highly recommend it. So when I hit run, what do we see? Well, first time we see 0, 15. Does that make sense to you? Does it? Yes, no. If it doesn't, why? Well, I call it with 15, and it's 15. Counter is 0. Is 0 less than 15? Help me. Who said yes? True. There we go. Then what do we print out? Counter, which is 0, n, which is 15. Increase counter. Then it should be 1. And I'm printing out n every time, but it's always going to be 15. 1, 15, 2, 15, 3, 15, 4, 15, and so on. Okay? That's all the function is doing at this stage. However, we're obviously not done. Okay? So, I'm going to give you one more hint. All right? First of all, I'll give you a third hint. Remember that if you do mod 2, if something is evenly divisible by 2, is it odd or even? Even, right? And so mod divided by, mod 2, right? There's that hint. But here's another one. Have another variable that is not incremented. Like counter is the variable for like the loop, okay? But have another variable running total and make use of that. And I'll give you a few more minutes to see if you can work through a solution. All right, here's what I've got. All I did is I added this. Okay, if counter mod 2 is 0, that checks if the variable counter is even or odd. If it's equal to 0, it's even. If it's odd, I'm not going to do anything, I'll skip it. But if it's even, what do I want to do? I want to keep track of the sum of all of the even numbers along the way. So I'm going to take running total plus equals, if I'm in this if statement, what do I know about counter? It's even. So it's an even number. I need to add it to the running total. Do you see? What does the code say? And I need you to participate, okay? I put in, let's say 15, okay? 15. Counter is 0, running total is 0. Is 0 less than 15? True. What is 0 divided by 2? What's its remainder? Oh, so it's even. So running total, which is 0 plus 0. Okay, cool. Print. And you know what? Here, let's add. There, I'll run it again, and we can kind of see how it was changing, right? Increment counter is 1 less than 15. Come on, wake up. Is 1 less than 15? True. Wonderful. What's 1 divided by 2? 0. Integer division. 0. Remainder? But what's the remainder? Okay, one person got it. Everyone else seemed rather not confident about the number 1. I don't know what's going on there. So it's not 0, is it? So I skip it. I print it out. We see the 0 again. 1, 0, 15. You see? Increment counter, it's 2. Is 2 less than 15? True. What's 2 divided by 2? Remainder? 0 is 0. So running total, which is 0 plus 2, it's now 2. Go down, we print it out. 2, 2, 15. Increment, it's now 3. Is 3 less than 15? True. Is 3 divided by 2 is 1, remainder 1. It's odd, we skip this. Print out 3, 2, 15. Increment it, 4. Is 4 less than 15? True. 4 divided by 2 is 2, remainder 0. It's even. So 2 plus 4 is 6. 4, 6, 15. And so on. There's no trick to this other than what does the code say? If you've made it this far, you can follow the code. Don't try to skip any steps. Programmers are stupid. If you try to be smart, it won't work. Try to be stupid. What do the simple steps say? Follow the code. That's the only thing that you can do here to figure this one out. Yeah?
You make it even simpler.
Of course we can. So how could we make it simpler?
You just, instead of using the modular, you just step by 2, just add each one so it cut down any operations. You don't have to check all of them.
So you're saying just do this. Oop. Right? Did anyone do it this way? Yeah? So how does this one work? Oh, I guess in the end, we never return the final result, right? Return, running. No. There. There. How does this one work? Well, it starts at 0. Add 0 to running total. It's still 0, whatever. Increment by 2. So we're effectively counting by 2s, meaning every number is going to be even. So if we count by 2s, counter goes from 0 to 2, add it, to 4, add it, to 6, add it, and so on. Do you see? It's pretty neat. So that's another implementation of this solution. Now, is it better than the other one? Maybe. Depends on what we mean by better, but we'll talk about what makes an algorithm better, worse than others a little bit later in the course. Do we have any questions about this? If this was immediately obvious to you, fantastic. If it wasn't, this was tricky. It's not supposed to be. If you're new at this and this was immediately obvious, okay, good job, you're doing something right. But in general, if you're new at this shouldn't have come to you like that, right? Try it a little bit, we work through it together, you're fine. Don't let this think that you should have known how to do this immediately. No. Okay, any other questions about these while loops while we're here? Okay. Strings and objects. All right. So, you may have noticed that strings behave a little bit differently, and they are a little bit different when compared to the other types that we have been using, like floats, ints, booleans, okay? Strings are a little bit different. You know, traditionally speaking, not so much in Python, but traditionally speaking, strings are made up of individual characters, okay? And what's nice about a character to a computer, in the same way as like an integer or a boolean, is if I have an individual character, all of that data has to be stored in the computer somewhere, okay? And the computer likes to store things in nice discrete pieces, okay? So a single number can fit in one seat really easily.
I didn't get that. Could you try again?
Interesting. Who is that, Google or Siri or whatever? Siri, get out of here, Siri, yeah. Another number can fit right in here just fine, right? A letter can fit in this seat just fine. Each piece of data fits into a seat really nicely. But strings, okay, if an individual character can fit in one seat, but I have a string, which is a collection of characters, a string of characters, if you will, and that string of characters can be arbitrarily long. I mean, it could be 1 letter or 50 letters or 500 letters long. How can I fit all of those letters into one seat? The answer is you can't. There's only enough room for 1 letter in one seat. I can't fit more than 1 in a seat. Yet we can have strings, variables storing strings. So how the hell does this work? We're going to learn a little bit about this. Knowing all of the nuance of what I'm going to be talking about in the next few topics is not required. But I will, like I'm showing you for completeness, but I will make an emphasis on what we really need to wrap our heads around, like what's the really big point that we need to pay attention to for our purposes. I will make that clear. But a lot of what we're going to go, I'm going kind of like deep into like the engineering of like how these systems work, traditionally speaking. But you know, that's just edification, right? But in general, I will make obvious what we need to know. Now, and so by the way, with strings, like you may have observed before, you can index strings with these square brackets, right? If I've got some string, hello world, and I say some string in index 0, I'll get an H, an individual letter. Why an H? Well, it's the letter at index 0, because remember we start counting at 0 because the indexes are all offsets. Go to the beginning and take 0 steps. I'm still at the beginning. If I say go to index 4, that should be 0, 1, 2, 3, 4. We should see an O. If I said 5, what should I see? Comma. If I say 6, what should I see? A space. Yeah, exactly. So, yeah, this is talking about 1. Yeah, okay. All right. So, let's just do this one together real quick. Write a single line command to print the first characters of some string. Well, whatever. Let's. Okay. Conveniently I did 4 and I see nothing. By the way, you can kind of confirm that there is a space because I can like highlight it. See? Oh, see? Right? We just can't tell. All right, well, there's an S, but the space was there. I just, you had to like highlight it to see it, which is kind of neat. Anyways, okay, cool. All right. If you have I'm just going to show you this one. This activity is kind of, I feel like it's in reverse order. If you want to get the length of a string, use this function called len. Len for length. Oh no, I called it ASD. There. 11, right? So I say, what's the length of ASD? ASD, well, it's 11. Why? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? Now what's interesting about this, and listen closely, so there's 11 things in this string, right? So ASD at index 11 is what? It doesn't exist. It says index out of range. Why does it not exist? It's not a trick question. If this has a length 11, and I say, well, give me the character at index 11, how come it's saying it's out of range?
Because the 11th character is at 10.
Exactly. The first character is at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So 10 would be the last one. Okay? Cool? Right? Now, what's neat about Python is, if you want to get, if I told you I'm going to give you some arbitrarily long string, you don't know how big it is, but I want you to tell me what the last letter in that string is. How do you do it? Well, if you know how long it is, I could just be like, well, the length is 11 and then do -1, right? Like I can hard code that and say, like, give me the 10, okay? But if I don't know how long it is, I do the same thing, but in code, is I get the length, -1, right? How did that work? Well, I'm going to say, go to index. Well, what's the length? 11. 11 minus 1, 10. So ASD at index 10. That's what that does. Yes?
Can't you also just print ASD -1?
So what that is, and I said this before, so this is how you do it. This is the functionality of getting, like this is the code, this is the syntax one would write to mean explicitly get the last value. But Python, not a lot of languages have this, but some do. Python has a lot of, and I've used this word before, syntactic sugar. Remember I said that before? Like elif is an example of that, where like, oh, it's just a little nicer than writing like else, if, and whatnot, right? It's just nicer syntax. Python has syntactic sugar that means exactly this, but it makes it a little easier for you. You just type -1, and it'll give you the thing at the end. What do you think -2 will do? The second to last thing, right? Now what it means is that's what it means functionally as far as Python's concerned, but with this syntax, Python will be like, oh, they just mean, yeah, the end, okay? Now don't get it twisted, this is just syntactic sugar for what we just saw. Like it means the same thing, it's just like cleaner, simpler syntax, that's all. So that's handy. Another cool thing you can do, and this is a Python thing, and I don't do it that often because I try to, like when I'm teaching people intro programming featuring Python, I go out of my way to try not to use too much like Python-y stuff for the sake of showing you how it would work in general, not know how you would do it in Python, and then when you go to Java and you're like, how come I can't do this in Java? So I try to teach the more general way. But here's a neat thing you can do in Python. It's called slicing. I could say, okay, ASD at index 2 is the letter M, okay? If I say, give me all of the letters from index 2 to index 8? It does. I can put a colon in there. That means go from 2 to 8, but exclusive. It'll go from 2 to 7. It won't include 8, like everything else, right? So 2, 0, 1, 2, M, 3, 4, 5, 6, 7. We get to the R. Pretty cool. That's called slicing. Another neat little thing about slicing is you can add another one, which means like, but go by 2s. So start at 2, 4, 6. So that's why we see fewer things, which is kind of neat. Also, if you do like 2 colon and you don't include a second number, it'll go 2 to the end. If you do colon 8, it'll go from the beginning up to, but excluding 8. So that's kind of neat as well. What if you're like, well, I want to go from 8 to 2? Okay. It's not going to work. It gives you back nothing. Because like it's like, okay, give me all the letters between index 8 to 2. You can't go that way. You have to go backwards. But if you remember, that third one lets me decide how to count by. And that will work, which is kind of neat. All right? You see? Go from 8 to 2, counting by negative 1s. Because otherwise it wants to count by 1s, and I can't get to 2 by going 8, 9, 10, 11, 12. I'm moving further away from 2. I can't get there. So that's just a little bit of strings there. Now there's another type of loop that is like an enhanced for loop. Or, never mind. It's basically a for each loop. A while loop is a very good general purpose loop. All right? So vertical print while. What is this function going to do? Print out the string vertically. In other words, print out a single character on each line. Okay, cool, perfect. I'm just going to take this code. Let's run it. If I call vertical print while, and I'll do like, okay, I'm going to call this function and give it a string. And we see what it does, right? Okay? Why does it do this? Well, it takes the string hello world, character index 0. 0 is less than the length of that string. Go to that string, index 0. Print it out. We see the H. Increment it. Now it's 1. Print out the thing at index 1. Do you see? Right? It's the index that's being incremented. And every time we print, it adds a new line. So that's how I'm getting the new line thing, right? But by incrementing the index, each time through the loop, I can index a different thing. Pretty neat. Now, a while loop is a beautiful general purpose loop. What makes it general purpose is any condition can be in here that evaluates to a Boolean. All right? It is so common, though, that you have something like this, where I have a collection of things, like the string. It's a collection of characters, okay? Where I want to do something for each thing in the collection of things. I wanted to print out each character in the string. Character, the thing, in the string. The collection of things. Okay? It's such a common pattern that Python gives us something for it called a for loop. It's like for each. So for each char in a string. All right? So this is the same functionality but look, it's 2 lines of code. It's going to do the same thing. For each thing in the collection of things. That's what that means. So if I call vertical print for, it's going to work just fine. Pretty neat. So it's just a simple, it's almost like syntactic sugar for such a common pattern, right? The while loop, yeah, we could use a while loop for this, but a while loop is a very general purpose tool. A for loop is a specialized tool that makes it, it's so common that we need to do something for a collection of things that we get this for loop. It's really handy. Any questions about the idea at this stage? Yes?
What is char? Can we just put in any variable?
Yes, that's exactly where I was going to go next, and great conclusion. This is the collection of things. Now, why did I call it char? It didn't have to be called char. I could call this. It does not matter. It works just fine. Now, I called it char because it's a character and that's a good variable name. But this is the variable name that I'm going to use to refer to the current thing. Print out the current thing. This, it matters because, well, this is the thing I want to go over. So I would have, like, the string, in this case, that stays, but whatever I call this doesn't really matter. I mean, I could call this whatever I want too. And then I would just have to have that there, right? But the point here is char, it doesn't have to be called char because they're character. It doesn't have to. It's just a variable, right? In fact, it's common to just see like C. Like that wouldn't be unheard of in this particular situation. I still prefer char or maybe even better character, but you know, there's nothing wrong with that. Pretty neat. So this is just different syntax to do the same thing as this. It's the same thing. It's the exact same functionality, but Python gives us such a convenient syntax to do that because, again, it is such a common pattern. General purpose loop, condition. Whatever condition, I don't care, run that code for that loop. Here, for each thing in a collection of things. If there's 100 letters in that string, how many times will that loop run? It's not a trick question. If there is 1 billion letters in the string, how many times will this loop run? 1 billion. Yeah. For each thing in the collection of things. In fact, like I could do something like this too if I wanted. Like I can still create a counter and increment it inside the loop. That's fine. Doesn't really matter. I can do whatever I want, right? Even though I'm not using a counter in like the while loop, it doesn't matter. I can do whatever I want with code. It's going to do what I tell it. You see what I mean? You have a question?
Could you go like for C, comma, counter in a string and then bake it in?
In here?
Yeah. Like, could you add anything into that?
Yes, and you'll see. Okay, I don't have it here, but yes, I'm going to just show you for fun. So he's like, well, what if like look, because this is also very common where maybe you do want a counter to go along with each thing. You want to know like which index you're at the same time. That's where you do like CI in enumerate. If you use the keyword enumerate, oh, what do I have wrong here? Count, oh, it's because it should be I. There. Although it looks like I've got my C and I mixed up, where maybe this should be like I and C there, right? If you wrap the thing in enumerate, it'll give you like the index or like the number of times it's run and the value, the thing, right? So it's kind of nice. But more on that later. Yeah. Other questions? Raise your hand if you have experience in like Java or other programming languages. Now, you might be like, oh, it's not the same as like the for loops you're used to, right? The for loops you're used to is like for int I equals 0, I less than. You're right. We can still do those loops in a way with a for, we'll see shortly. But these types of loops are equivalent to the enhanced for loops in those languages, like your for each loops. So Python doesn't really have that for I equals 0, blah, 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 blah. But that for loop is really just like a fancy while loop anyways. But whatever. For those of you that don't know what I'm talking about, it doesn't matter. All right, yeah. Okay, the while loop will continue to run while the condition is true. The for loop will run for each thing. The for loop will run for each character in the string. If I had a list, we haven't really learned about lists, but we've seen lists. If I had a list, it would be for each thing in the list, each element of the list. So first time through the loop, char would be H. Second time, E. Third time, L, O, and so on. The while loop, it's perfectly fine, but you may find the for loop is nice. And yeah, like I was saying, based on your question, whatever you call, you can call it whatever you want here. It's just a variable name, but you should give it a good variable name. Now, you may be thinking to yourself, okay, so if I have like A equals hello, okay, and I can say like print A at index 0, right? If I can get a value from an index, can I change the value at that index? Here's what I mean. Like, okay, obviously I can do this, like A equals 5, right? And yeah, I change what A is, right? Okay, fine. But here's what, oh, we'll get rid of this. Close. But what if I were to say like A at index 0? If A at index 0 is this, can I be like it's equal to X? This is what I'm wondering. Can I do this? If I can get information, can I set information? And let's see. No, you can't. Strings are what we would describe this by saying strings are immutable. Immutable means you can't change it. Alternatively, if I could change it, we would say it's mutable. We can mutate it, we can change it, okay? But strings are immutable. You can get information from it, but you can't modify anything inside of it. All right? So if you try that, it won't work. But if you say to me, no, I really want to change it, right? Don't tell me what I can do. I want to change it. I'm going to say, you can't. No, I really want to change it. You can't. But here's what you can do. Is you can say, well, if I really want to modify what it is, I can say, well, okay, give me A from index 1 to the end, X concatenate with the string from index 1 to the end. I can make a new string based on the old string, or a part of the old string. And this will work. Okay? Right? And so you're like, well, no, now you changed it. No, I didn't. You can think of it like this. The string hello exists right here. I can get information out of it. I can't go in here and change this. If I want to change it, it's not going to work. That won't work. Python won't let me. That's why it like crashed on me. I can't modify it. But here's what I'm doing here. I'm saying, no. Okay, forget this. Make a new string with the letter X concatenated with LO. Take this chunk of this one and concatenate it with X. Now I've got a whole new string. This one's left alone. I mean, the variable A had this in it. Now it doesn't. But I made a whole new string based on an old string. That's what I can do. So although I can't change it, I can kind of get that functionality by making a new one based on the old one. But the old one is still left unchanged. which is pretty interesting. And this is going to be a common idea going forward. You might think to yourself, oh, that's kind of an annoying limitation. You might think that, but in reality, programmers really like immutable things. We actually are terrified of mutability. We prefer them to be immutable. It's safer, easier to test, far less likely to make a variety of mistakes. But this is an idea we will explore as we go. So here's me showing you the same idea. I can have a string, I can go 0 to 5 and concatenate it with that, and then 6 to the end. Yeah, same idea of what I just showed you. All right, have a great weekend. I'll see some of you this afternoon.